We call functions periodic if they repeat over a certain period. So if you get back to the same values, you have a periodic function. So a function is periodic if the function of t plus p is equal to the function of t for some constant p. And the smallest value of p for which f is periodic is called the period. So let's think about the circle. We've got this unit circle here, and I start at the point 1, 0, where the cosine of t is equal to 1 and the sine of t is equal to 0. And so if I go through my values, that's going to happen again here. And then I can circle again. It's going to happen again. Every time I go around the circle once, I'm going to get back to 1, 0. And so cosine and sine are both periodic of 2 pi because the sine and cosine will repeat every time you go around the circle completely. Tangent, remember, is y over x. So remember, quadrant 1 is positives, quadrant 2 is negative, positive, quadrant 3 is negative, negative, quadrant 4 is positive, negative. In quadrant 1, tangent is positive. In quadrant 2, the tangent is negative. In quadrant 3, the tangent is positive, and in quadrant 4, the tangent is negative. And so notice the tangent is positive in quadrants 1 and 3, and it's negative in quadrants 2 and 4. So tangent has a period of 1 pi because it repeats every 180 degrees. Because if you're talking about pi over 4, the tangent of pi over 4, that's taking root 2 over 2 over root 2 over 2, which is just 1 whole, and the tangent of 5 pi over 4, which is also 1. And so tangent and cotangent are going to be periodic of pi. Secant and cosecant are going to be the same as sine and cosine because they're reciprocals, and so they are periods of 2 pi. So periodic 2 pi period functions are sine, cosine, cosecant, and secant. Pi period functions are tangent and cotangent. And what that means is I could take the sine of t plus 2 pi, and that's going to equal the sine of t. So sine is 2 pi periodic, that's 360 degrees. And so the sine of 2 pi plus t is the same thing as sine of t, or the sine of theta plus 360 is equal to the sine of theta. The last thing we want to talk about is even and odd functions. Even functions are symmetric about the y-axis. Odd functions are symmetric about the origin. An example of an even function is a quadratic function. Anytime you put in a negative, that becomes squared, you get back the regular function. An example of an odd function is a cubic function. If you take this first quadrant and you rotate it 180 degrees, you get the same thing. What happens when we are dealing with cosine and sine, cosecant, secant, tangent, and cotangent? Are they odd functions? Are they even functions? What can we do? We can look at, let's say, cosine of pi over 4 and see what happens if we have the cosine of negative pi over 4. The cosine of pi over 4 is root 2 over 2. The cosine of negative pi over 4, that's the same thing as 7 pi over 4. That's also root 2 over 2 because remember that cosine is greater than 0 in the first quadrant and in the fourth quadrant. So when you plug in a value for theta and the negative value for theta, you get the same value out. That means that cosine is even. What about for sine? Well, sine is positive in the first quadrant and sine is negative in the fourth quadrant. And so let's look at the sine of pi over 4. That's equal to root 2 over 2 as well, but the sine of negative pi over 4 is equal to negative root 2 over 2. And so it's the negative function. So sine of theta is an odd function. Well, what about tangent? Tangent is also an odd function. And then our reciprocals should then have the same properties. So the secant, because it is the reciprocal of cosine, is also an even function. And then cosecant and cotangent are both odd. So I think it's easier to remember that cosine and its reciprocal are even, and then everything else is odd. And that's all we have for this section.